Hello everybody, welcome back. Today we're going to finish the last example number 4 from section 7.2, locating a vertex using technology. So I kind of did that in the last video, but I'm going to show you how to do it again, and it's nice to see it a few times, right, until you get the hang of this. So it says the ski jumper was recorded in a frame-by-frame analysis and placed in one picture as shown. I don't have the picture, so I can get rid of that, I guess. I don't have that diagram, but I can get it for you. It's probably located in your textbook. All right. So if you want to take a look at that, it's on page. So there's the picture there of the skier frame by frame. That's what they're referring to. Okay. So y is going to be your vertical axis, and that is measured in meters. And x, remember, is your independent variable on the x-axis. That's in seconds. And there's the function. Okay, so we're going to graph this function on the graphing technology. So I'll go to my graphing calculator. Remember, I'm still in my graph from the last one, so I would just hit clear. All right, clear again, and then we can put that in. So we got y equals, and it was negative 4.9 x squared. Oh, sorry, I should have cleared that right at the beginning. I cleared the whole thing. Sorry, negative 4.9 x squared plus 15 x plus 1. We'll graph it. All right, so you'll notice we're missing some of the graphs. So I'm going to teach you how to fix the window up. So remember here, we don't need any negative time, so we don't need any here. So basically, we just want this quadrant 1 for the most part. So we'll go to window. Our x, man, we can make that 0 if you wish. And we can go up by 5s. So 5, 10. And here we'll make this 0 as well. And remember, this one went up a little higher, so I'm going to try 15, and we'll go up by 5s, and we'll graph this. It's a little better, but we didn't need that much, so go to my window, and I'll make the 10, 5. And I'll go by 1s, just so you can see each roughly where it's at. That's a little better. So this here is our curve. There's our vertex. This is the x-axis, so the time axis. So this would be 1, 2, 3, and a little bit more than 3 seconds. And this would be a height of 5, 10, 15 meters. Right up here. So probably around 12 or so. So I'm going to show you how to find that vertex value. Again, I showed you in a previous video, but I'm going to show you again. So once you have it graphed, just hit second function, trace, which is calculate. And before I showed you it was a minimum because it opened upward. Now this one opens downward, so we hit maximum because that's a maximum value. All right. So it says left bound, so you got to go to your left cursor until you're on the left-hand side of the vertex, anywhere. Hit enter. Go over the vertex. Go on the right bound, so it says right bound. Hit enter again, which is the bottom right-hand corner. And then it says guess. Just hit enter for a third and final time. And there is your maximum value. The y value is your maximum. That's one you're concerned about. And so that means the maximum is approximately 12.5 meters at approximately 1.53 seconds or 1.5 seconds. That's what that represents. Okay, so I like to use Desmos. This is how you show it on your graphing technology, but I'm going to do it on Desmos as well with you. So we're going to put that in the equation. Y equals negative 4.9 x, and then in the bottom right hand corner it brings the keyboard up if you want to get your squared and stuff. Plus 15x plus 1. Remember, we don't need this big of a graph, but we can leave it like that. Okay? But if you want to change, you just go to tools and you can play around like with your values. Like for our x, right? We don't even need the negative, so I'll just put like -1 just so you can see a little bit of it. And then we only went up as high as, well, 5 is more than enough, right? Okay. And then my y-axis, I'll go -5 just so I can see a little bit of it. And I think it went up as high as 12, so we'll just do 15, right? And there it gives you an idea of your graph, right? So that's a point that we're going to be interested in, not here today, but there you go. And there's vertex, which we calculated before. And they rounded it for you. Okay? And those are some key points there that I would like you to start getting the hang of writing in. Okay? So I'm going to clip this, take a snap picture of this, roughly. There we are. And there's my graph, right? And you can do that same thing here. All right? So you can make this like 1, 2, 3, right? And this can be 5, 10, 15, similar to the graph I showed you. Okay, and I'm going to do that with you in class. And there's your graph. Okay. So graph the function. We did that. Sketch, remember, some key points. Then determine the skier's maximum height to the nearest tenth of a meter. Right? And we did that. That's the 12.5. So we can just say the maximum height, and it's set to the tenth of a meter, so that's one place after the decimal. So the maximum height of the skier is approximately 12.5, and it was in feet or meters? Meters. It's quite high. It's quite high. And state the range of the function. So the range is the y value, right? So the y value is, for a range here is I'm going to say 0 less than or equal to y less than or equal to 12.5, right? So it has to be somewhere between here and here. This is obviously into the ground. Again, some would say all this the hill depending on that, but that's what assumption we have to make. So there's your range. Okay. Another way to show this, you may have were taught last year. You could show it as a so this is set notation, right? Or you could have put down what's called interval notation. So it could be square bracket 0, comma 12.5, close your square brackets, and that's another way to represent range. You can do either one. It really doesn't matter to me. It'll just depend on what your teacher showed you. I showed both with my classes. So this is interval notation, and sorry, this is interval notation, the second one, and the first one is called set notation. And you can show that either way. All right? So that's it for me. What you're going to do is you're going to look at the homework questions located on page 368, 1, 2, 3b, 6, 7, 9, AC, and 11 are some of the ones I thought would be beneficial for these questions. So thanks for watching, and we'll talk again next when we do solving quadratic equations by graphing. So I've been doing a little bit of hybrid, a little bit of both, because I think the graphing is it's great to do. It's time efficient, and it's great resource. I find it helps really understand the situation. So thanks again, and we'll talk again soon.